as you just heard, I'm with CenturyLink, and I'm sure that many of you have heard of CenturyLink, but some of you may not know that we're a lot more than a telco. So for the next 15 minutes, I'm going to give a brief introduction to who we are. I'm going to talk about Docker, what we're doing with Docker and microservices, or microservice-oriented architectures, and then I'm going to highlight a couple of the open source tools that we've created. Just by way of kind of a little bit more detail, CenturyLink is the second, we're the third largest telco in the US. Last year we had $18 billion in revenue. We're the second largest data center provider worldwide. And a significant portion of our revenue comes from financial services companies. So in fact, half of all securities transactions take place or are executed in our data centers. So your customers are our customers. I wanted to mention that because we have a booth right outside out in the hallway here, and Paul is here today. He's actually one of our ISV account managers, and so if you want to talk to him about getting your technology on our platform, please stop by. So the agenda that I have for today is just to give you a little bit more of a background into the CenturyLink cloud itself, introduction into Docker, do some live coding, which I know we all like to do, and talk about our open source projects. So the CenturyLink cloud platform is basically a developer-focused, it's a very open source oriented programmable cloud with a vibrant partner ecosystem. And we have infrastructure as a service, platform as a service, bare metal, it's a programmable API, upfront pricing, powerful user interface, and rich partner ecosystem. So this is we're really proud of what we've done. As you saw in the prior slide, I actually came from AppFog. That was a platform as a service company that we've embedded into our cloud. So the team that I'm a part of now is what we call the enablement team, and we help the customers, we help our end user or our customers adopt these cloud technologies. And one of the things that we've spent a lot of time on over the last 18 months is working on Docker and finding ways to help our users leverage Docker as part of their IT infrastructure and processes. I put a little shameless plug in here. Connexio actually is one of our partners. They provide a secure video chat for financial institutions, and so their customers can communicate with their financial advisor or loan officer in real time. That's the type of service that they provide. But coming back to Docker, this chart kind of shows what's been happening over the last couple of years in terms of this new technology. And what I'm going to do is try to get into why it's so compelling and what makes why Docker is taking off in such a big way. As you can see, virtualization's been around since the mid-2000s, and OpenStack kind of started taking off at the beginning of 2010 or 11. But in the last couple of years, Docker has just exploded. We've got a handful of financial services companies who are already starting to introduce Docker into their development pipelines, and for the rest of the presentation, I'm going to be talking about Docker, and in particular, this is really targeted more at developers or anyone that wants to get a better understanding of containers, how to create containers, how to use them. And so I'm going to be doing a kind of a brief overview of some of the basics, and then I'm going to do some coding. And hopefully this will be enough to help you understand how to package your code into a container. And then we'll show you some of the open source projects that we've created that can help you to start adopting and implementing Docker with your applications. So what is Docker? At its core, Docker is really just a packaging tool. It sits on top of the components of the Linux kernel. And it packages up application code and dependencies into an isolated execution environment. And that's really all it is. However, there's a lot of benefits that provides when it comes to managing your software lifecycle. The biggest thing is it also does have a limited scope, though. There's a lot of things it doesn't do for you. It's not a scheduler or orchestrator. There are other tools, though, that provide those kind of capabilities, and we'll talk about those a little bit in coming up here. So as I mentioned, it's a container. A container is really essentially it's a self-contained execution environment. And think about it as something that's in a box that's isolated from everything around it. And because it shares the kernel with the host operating system, it's very fast, but it has very low overhead. And this is the reason why containers are so much, we think, so much better than virtual machines. I don't want to completely ignore that there are some disadvantages or some things right now about containers that are less mature because this is an emerging technology. The biggest issues right now are security concerns and cultural adoption. But these are common issues for a lot of technologies, and there's a lot of teams and companies hard at work making these, addressing these issues. So these are just mentioned again some of the key performance benefits. So I like this slide right here. It just kind of shows, this is really illustrates how a typical virtual machine is set up. You might have, in this case, you've got 3 VMs next to each other. You know, 2 of them are running the same application, and then as you can see, each of those applications have their own libraries, and then they're running on top of their own guest OS, and then they sit on top of a hypervisor, which sits on top of the underlying host operating system. In the Docker world, though, we can get rid of the hypervisor and the guest OS because there's really no need for them. And instead, these are replaced by the Docker engine. And the Docker engine basically is able to rely on the host OS for all of its operating system functionality. And then because with Docker, when you build your container, you're essentially layering on each of the services that container will use underneath it. And so in this case, we can see that since application 1, they both are going to be using the same libraries, they're shared. And so the result is that containers have a lower footprint because Docker consolidates a lot of the common layers. And they also have much faster startup time because you don't have to worry about booting an underlying operating system. So how do you define what a container is? All of the commands that define a container are inside what's called the Docker file. But besides this part, everything I've just talked about, which is the execution engine and how Docker works, there's also something else, and it's also a development workflow and ecosystem. And this really benefits the developers and the ops teams. So in this case, we have what's called the Docker Hub, and it's where the developers and ops people can go and share images. It has a lot of official images on there, so these are typically submitted by companies and organizations that have already that have an official image that they want to release. And so I imagine some of you in here may already have some of your software, potentially if it's open source, in the Docker Hub. But for those of you that don't, this could be another great venue to get people using your product. So for example, if you wanted to use MongoDB, you could just go to the Docker Hub and download that. But as I mentioned before, one of the biggest challenges in getting started with Docker is getting used to kind of the layers of abstraction that exist between you and your code. And so that is one of the challenges with adopting Docker and starting with it. And that's why I wanted to, hopefully in this really short presentation, I can at least kind of show you how easy it is to get started. But that is one of the bigger hurdles. So this past spring, Docker actually released what they call the Docker Toolbox to kind of make it easy to get started. It has a Docker machine, which is the binary, as well as the Docker engine. It comes with what's called Docker Compose for managing multi-container applications, which is really, at the end of the day, that's really what this is all about. And then it has Oracle VirtualBox for running your VMs. So once you've got Docker installed, it's pretty straightforward. Then you can interact with it using the command line interface. And I want to just mention one more thing before we continue, and that is that there's 2 approaches for developing Docker images. One is just to create a static, production-ready type image. And the other way is, during development, to do a more kind of dynamic approach. And today, just in terms for simplicity, I'm going to do the static production-ready approach, which I know kind of seems counterintuitive because this is we're going to do some live coding, but it's a little bit easier to do, and I think a little bit easier to understand. So just keep that in mind. And also, I want to be using Ruby, but that's because that's what I'm familiar with. I know a lot of you out there may use C++ or Java or .NET or whatever language you want. It doesn't really matter. Docker is completely language agnostic. It's simply a packaging tool, so you can use whatever language you want. So what I'm going to do right now is just kind of run through really quickly how to basically create a Docker image, and we'll do this in real time. So as I mentioned, you use what's called Docker file. And so here's an example Docker file. The most important thing here is that the very first command has to be where it's pulling the root image from. There is such a thing as a what they call a minimal, or it's called a scratch image, but for the purpose of this presentation, we're going to be using Ruby base. The next instruction, actually, so one thing I'm going to do real quick before we continue. So I'm going to kick off this build command. And actually what this will do here is, let's see. So I've got a basic, simple hello world app here. And I'm going to build this while I'm talking. So, oh, well, it's already over. That was fast. And I think I already mentioned, so this first command, this is first line, is the from. It just specifies where the base image is coming from. This is who to blame when things break, so that would be me. And then this next thing here, this is an exposed port. So the way you interact with containers is via their ports. That's how they communicate with each other, and that's how other tooling will communicate with the containers via those ports. So then the next thing I do here, and for this particular Hello World app, is I create a directory really quick, and then I copy all the content from my host directory where I'm running this command from into this new directory. There's also a command called add, but typically copy is the preferred way to do that. The next command here is called workdir. This basically sets my workdir. And one thing to keep in mind, or working directory, is that for each of these commands that you're seeing, each one actually is adding a new layer onto your image. And so in the process of building an image, you actually create a lot of interim images, but those are kind of discarded, and at the very end you have your final image. And so the reason why workdir is important, though, is as I said, each time you build a new image, it doesn't know anything about the state or the context from the prior image. And so finally, this is the last command. This tells Docker what to execute when it starts the container. So at this point, I've already shown you what a typical Docker file, or a very simple Docker file, will look like. There's a couple more key commands, though, that should go into Docker file. One is your environment variables, and that's how you would pass them. And the second is being able to set volume or mount points so they can access your host directory. And this is earlier when I referred to doing development, more dynamic. This is how you do it, is you would set up a volume mount point to access your existing directory. And that way you don't have to rebuild every time you build your image. But once you ship it to production, you would obviously use more of the static approach that I'm taking right now. One of the cool things about Docker that makes it really great for heterogeneous development environments is you can have, it gives you a lot of flexibility. So you could have one development team is using Java 6 while another one is using Java 7. So let's see here. I'm going to go back and I'm going to go run this container. Oops. All right, so I just kicked off this Docker container. So I noticed that I'm passing a port command right here. So that's telling me that earlier in the Docker file, you saw that I was exposing port 4567. So now I'm saying I want to map that port to my local host. So here we go. And yes, all right. So, so as you can see, it's a very simple Hello World app. But what I've done here is this is a container that I kicked off. So I'm going to go back to my console here, and you interact with Docker using the command line or the API. So you can see the name of my application that's running is actually Goofy Feynman. But the image that it's running is Hello World. And in Docker, you basically think of it, it's like a class that you've defined your class, and then you instantiate that class and you run that container. So Docker stop. So in theory, I could have other containers running as well. And I wouldn't want to stop all of them. I just want to stop this particular one. So I have to identify essentially the object or the instantiation that I've started off. So let's see here. So we created a few open source tools to help developers leverage Docker. One of the things that you want to do is you want to minimize the footprint of your container. And so I'm going to go to, we have a tool that we created called image layers. And this tool is, let's see here, I'll go ahead and expand this. This tool it's open source, it's free, it's available at GitHub, CenturyLink Labs. And here's a list of all of the tools we have freely available. And there's image layers. But we're also running image layers as a hosted application. And so what you can see up here is I've got image layers running, and it's actually comparing some of the popular, basically, base images. So it's got Ruby, Python, Node, Golang, and Java. And you can see that for each layer, some of them, they all have the same layer in common. And then as with each line in that Docker file that's defining these images, you're starting to see some still have the same lines in common, but as it goes down further, you start to see that it breaks apart. The white is what's used for a command instruction set. The light blue is for copy or add. The darker blue is a run, and then the greens are setting environment variables, just as kind of a by way of what they're doing. So this is actually a really useful tool. I actually did a little comparison earlier of Java 8, Java 7, and Java 6, and you can see that they have a lot of layers in common, and they start to separate. So I wanted to show one more tool, and then I can see that I'm running out of time, so I wanted to leave a little bit of time for questions. The other thing that you want to do with your containers, once you've got a few containers, you want to stitch them together into a microservice-oriented application. And the way you do that is using what's called Docker Compose. There are also other orchestration tools that you can use, but this is a really good way if you're going to get started. Just use Docker Compose. And so we created a tool called Lori, and we also host that at lori.io. And it allows you to create a compose file that's completely syntactically correct. It's just one of those things that sometimes if you do it in a text editor, you can end up having trailing white space or other things that cause it to break, and you can't, you have to spend a lot of time debugging it. This makes it so that you can create one right out of the gate, and it works really easily. So I think that I'm gonna end the presentation, my part right now, and and answer any questions that you guys have in the remaining minute and a half or so. Okay, so with a complex Rails app, I thought you said Plex, and I was like, okay, I haven't heard of this particular technology, so I'm just going to have to beg clean on that one. As I was mentioning earlier, one of the challenges with Rails development, or actually development of anything, is the time it takes to rebuild your image. And because Rails, a lot of times what you're doing is here's what I'd recommend is in your what do you call that? The file that specifies all the different gems that you are working with. If you know that you have a specific gem that you want to pull, you can put the version number in there. I think that sometimes helps because otherwise it's gonna pull that every time. So every time you build your container, it's gonna go out and pull those down, and that can sometimes add a little bit more time to the development process. Another thing to consider is just using an orchestrator tool like Kubernetes, or there's Mesos. Even Docker Swarm can be useful for once you get to the point where you want to start scaling your application. I think we're out of time for questions, so I'm afraid to ask for any more, but I appreciate your guys' your support, and like I said, we're going to be at the booth right outside, so if you have any more questions, please stop by.